Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you are amongst the 50% of the people who have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a link to Super Chat that runs alongside the show while it is live. And most importantly, if you would like to join the debate, there is a link in the info box below this video. With the page you are watching currently on mute, simply click that link to join the show and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number one, please do not swear. If you do, you will be ejected, but you will be warmly welcome back on the next stream. As I say, if you've not done so already, please share the show on Facebook, Skype and Twitter. I will do the same in a moment, and then I will transition across to the Hangout as we've been joined by our first couple of guests, who I believe is Miles Davis and Sleeping Warrior. So I'll raise the mic on them and say a quick hello. Bear with me one sec.
Good morning.
Hello, gentlemen.
Or afternoon now it is.
Miles Davis, as you were first. How are you doing, Miles?
I'm doing all right.
Morning, Nathan. How are we?
Good to have you. Right, I'm going to put myself on mute.
Does that mean we kick off? Is there any chance of getting a screen share here?
I've only come in to keep Miles under control with his gish galloping.
Yeah. Can I share my screen, guys? Or can someone present my screen?
Morning, Make 4.
Hey, mate.
How you doing, mate? Good to have you here.
Yeah, cheers. Good, thanks, good. Whoa, oh, man.
Can people see my screen?
Oh, I'm so glad you've done this.
They can now.
Yeah. I hope the audience can see. So there was a lot of chat about refraction last night, and a perfectly reasonable explanation was given by Paul, and it was completely ignored and laughed at. So I've very hurriedly put together a little set of diagrams just to try and explain what the situation actually is. So if we have no refraction, then light travels in straight lines to the camera, and
Ooh, I like this.
the lamps will appear in their actual position, and they'll have the appearance of curving downwards if they're on a curved surface. Obviously, if they're on a flat surface, then they would appear as being in a straight line. And so you can see that that's the curve that would appear. I can't draw a single curved line on here that fits easily, and I didn't have much time, so I've done it with arrows. Now, if you have a moderate amount of refraction, then the light from the lamps is bent, so that the light that would normally go above the camera, so light from here, from this lamp, going in this direction, would normally just go off up above the camera. But it is bent down so that it goes into the camera. Light that would be starting off going directly towards the camera would also be bent down and would go below the camera, would miss it. So the light entering the camera from each lamp is doing so at a different angle to the no refraction situation. It's not going directly to the camera, it is going in a curved path. And I've filled in a few more of these arrows showing the path of the light towards the camera. And if you draw a line back from the angle that the light is entering the camera, you get something like this. And here we have our lamps appearing to be in a straight line. The furthest away lamp having its apparent position being raised up more than the nearest lamps, because the light has travelled further and therefore had been bent more and therefore approaching the camera in a different angle. If you have a large amount of refraction, the effect is exaggerated. The further lamp is raised up. I haven't been able to animate this at a greater distance. And again, if you follow the line of the light approaching the camera back, then the furthest away one will be higher, and we get the effect that because of the apparent position of the lamps, that the lamps themselves are curving upwards, not downwards. Refraction of this type, refraction can be of different types, but refraction of this type perfectly explains the observations that Anthony took from the portion of Soundly's video that had a considerable amount of refraction occurring soon after nightfall, when there was a considerable temperature difference between the water and the air immediately above the water and the air a little bit further away from the water.
So,
So that's my little presentation. Is whenever you have refraction occurring, effectively you have a mirage. Now there are different types of mirages. Some are caused by the light being bent downwards towards the Earth, and then you can get a mirroring effect and an inversion of what you're seeing, and so on. There are many types of refraction, but this explains the observation that Anthony actually highlighted. So that's all I wanted to say about that.
Now I'd like to
and I'll shut up and see what anybody else wants to say about it.
Miles, let me respond, and I'm going to talk directly to you, okay? And you can listen to what I say, and at the end, when I've finished what I'm saying, then you can respond. So let me get my words out, and then you can interrupt at the end, or you can conclude at the end. When we're talking about refraction, Mick West himself cites a particular PDF file from MIT. This is peer-reviewed paper, True Science, and it describes the effect of it. It describes refraction as negligible. What you've just described looks brilliant. I'll give you credit for it. It looks great. You've obviously spent time on it, and it illustrates your perception of the truth. That's great. However, in this paper, when we turn to the relevant section about the conclusion of refraction, it reads, under standard circumstances, the effects are negligible. Now, I'm not seeing a load of refraction there, Miles. They were all pretty much straight. Now, that means that if the Earth's curved, we're either seeing huge amounts of refraction the way you're describing it, or in my assertion, it appears to be flat because it is flat. So if you're saying that there's huge amounts of refraction, you're still limited by the word negligible. And the word negligible is so small or unimportant as not to be worth considering or insignificant. And in context, it means refraction is negligible. So what you've just presented should be described as negligible, but you've clearly not described it as negligible because the last two were significant, and that's not refraction. Secondly, the refraction always goes down. It never calculates for it going up. You've demonstrated an up, and that's inconsistent with the maths, inconsistent with the science, inconsistent with Mick West's own citation. I'm done. It's over to you.
That's good. You said refraction always goes down, it never goes up. Actually, it always goes up in this particular description.
So why is it calculated on the Mick West website for going down?
I gave you the time to have your say. Would you please not interrupt me? Okay. I might need to share my screen again.
Well, just before we do, just let me flick back onto mine because mine's still on. If refraction always bends up, Miles, why is this calculating for a downward curve?
It's not.
It is.
No, it isn't. When you observe something in the distance at a higher elevation than its actual elevation due to refraction, the perception of that object has moved up, not downwards. The light is bent downwards towards the observer, the camera, or your eye, but the object appears to be higher as a result of that bending.
So
that's
then,
what my diagram has shown. So I don't know if
that would mean that boats never go over the horizon. Miles,
before you continue, sorry,
can I
just introduce Paul? Sorry to interrupt you, Miles. We've been joined by Paul. Very pleased to have you here, Paul.
Yeah, you're welcome. Pleased to be here.
Good to have you.
It is absolutely correct. Is that Paul there?
It is.
Morning, Paul, or afternoon, Paul.
Morning, Miles.
It's afternoon.
It's evening here. Very late.
Our cricketers did all right today.
Yeah.
Our cricketers did all right today.
That's good.
Yeah, so I was just trying to explain to Anthony why, really following on from your explanation last night, why refraction works the way it does. And I put together a very hurried little PowerPoint which shows
Yes, I
that
saw.
no refraction, light goes directly. Did you see that? Yeah.
Yeah, I did. Yeah.
And in this situation, the objects are raised above their actual apparent position. Now, Anthony, you said negligible.
Yes.
I have diagrammatically tried to represent the situation here.
Yeah, but have you been negligible with your?
If you look at your pictures that you've taken from Soundly's video, the actual amount of movement up or down, apparent movement up or down of those lamps is very small.
Yes, that's not consistent with your illustration.
Negligible is not a scientific term. It may have been used in that paper, but it is a meaningless word in many situations.
Meaningless word.
Things are negligible.
It's illustration that you guys are talking.
Things are negligible. Can I finish?
Can I just interrupt here for a moment?
Yeah, sure, Paul.
Yeah, can I just get Anthony to share his screen again and show me that yellow highlighted text that he got up before, please?
Oh, yeah, that would be fine. Yeah, I'll stop sharing mine.
Yep.
So, yeah.
Okay, can you put that back up again, please, Anthony? That
I'm just trying to
passage
find
that you had. Thanks.
Share screen. I can give you a link to the whole thing so you can read the context if you want, but trust me.
Yeah, I used to have that article, but I lost it, so I would appreciate the link for that. But I really want to see where you've highlighted in there.
Okay,
please. So
can you see my screen?
Not at the moment. I can see the video of the Soundly's, but what I want is the article where you've highlighted in yellow. The article.
Miles,
yes, that's it. That's exactly what I want to see. Now, I'm just going to read this here. It says, under standard circumstances, the effects are negligible. And then the very next sentence says, it is under non-standard circumstances when we really see some amazing atmospheric phenomena.
Yes.
Probably the best known is the inferior mirage. Okay.
Yeah.
So
carry on.
There's, yes, probably the best known is the inferior mirage, which occurs when lower regions of the atmosphere are much hotter than higher regions, such as in deserts. But what this is essentially saying, Anthony, is that under standard circumstances, the effects are negligible.
Yeah.
What it's then implying in the very next sentence is that under non-standard circumstances, we do see some amazing atmospheric effects.
So
and
are we
that
seeing?
Is what's happening. That's what's happening here.
No, it isn't.
That's what's happening here. And
is there a
Soundly made it.
Is there a
let me finish?
Is there a mirage? No, you are misrepresenting the evidence exactly the way Miles does.
That's just one of the examples cited in that paragraph, but I know that paper lists at least half a dozen other mirage effects that occur.
Yeah,
because
true.
I have
all
looked
of
at
which
it.
are crazy.
That's
Is
right.
this crazy, Paul?
All right.
Completely consistent.
No.
3 frames that I showed you, which were showing the minimum I found, the maximum I found, and the one in the middle.
No. So what the very next sentence where you chose to just quote and say the very first sentence there about under standard circumstances, the refraction is negligible, but you completely ignored the very next sentence, which says that under non-standard circumstances, we do see atmospheric refraction effects happening.
And Anthony, that's what's happening. Put up your 3 pictures again. Could you put up your 3 pictures again? I just want to see the timestamps on those.
So this would be described as atmospheric conditions that are non-standard.
Okay, that's fine. Ignore me.
I'll come back to you in a second, Miles. This would also be described as non-normal, non-standard refraction or not ordinary circumstances, because you are clearly seeing crazy stuff. Floating ships don't happen, right?
And so was the circumstances of Soundly's experiment in the evening when the temperatures were coming to equilibrium. That is non-standard as well.
No. Or is it simply conjecture based on your personal bias?
No, it's evidenced by Soundly's video.
The evidence
where's the evidence of
it shows that it changes from one thing to another. Something must be causing that. And the scientific explanation for that is refraction.
Where's the evidence in this image of crazy non-standard conditions?
You will see the evidence in the video, not in the image.
Right, right, but it does exactly the same
Because
thing.
you see quite clearly before those frames, you see the lights bending down. You see not the lights, you see the image of the roadway bending down in the daylight. As it transitions into the evening, you see it come up, and then later on in the night, you see it go back down again. It's during that period when the lights are up, that is the period where the non-standard atmospheric refraction is happening because the temperatures are equalizing.
Where is the evidence of non-standard circumstances? Because to me, look at the evidence. It looks totally calm. There's nothing crazy going on there.
You can't see.
The temperature changes.
So you're asking me to believe something that there's no evidence of because it suits your premise.
Could you go through each 3 pictures? I want to see the timestamps on those.
Right, 1903.
That's with it curving upwards.
Oops. 1828.
So that was earlier, and it was straight.
1837.
Right. So clearly, as the time has gone on, that refraction effect has got greater. Yes.
Wouldn't your model say it would settle down at that point?
No. Absolutely. If you go later in the video, you find it does settle down.
No, but it doesn't look that way, does it? At 1903, the latest timestamp on the images that we've got, it looks worse than ever before.
Anthony, the effect occurs at the time, begins to occur at a time just after nightfall.
What effect? Where is the effect?
Evening progresses. Anthony, can I finish a sentence?
Where's the effect?
As the evening progresses, the temperature differential between the air and higher above the water, near the roadway, presumably, or a little bit higher above the water, the temperature differential between that and the air near the water is greatest. As the evening temperature, as the evening progresses, that temperature eventually gets equaled out, and so it's even, and then you get less refraction occurring. It's a very, very obvious explanation for the observation that Soundly has made and you have made.
Yes, it's a very obvious explanation.
Ultimately,
where's the evidence to support its truth?
Just before you get into that, sorry to interrupt you guys. Sorry, Paul. Bear with me. Paul, sorry, bear with me.
Anthony,
Bear with me.
if you
Miles,
want to claim
Miles,
that it's
bear with
not
me.
the right explanation,
Hang on, Miles.
Okay, let's turn you all down because you clearly don't want to listen to me. Right, I'm going to introduce my latest guest, which is Curved Water. So if I can just say a quick hello to Curved, that'd be really appreciative.
Hi, Curved.
Good afternoon. Am I coming through?
You are,
Yep.
thank the Lord.
Late Curved, you're getting clocked 15 minutes.
So just before you get back into it, Miles, you're asserting something. Can you actually show us? You're saying it does this, that, and the other. Can you just show us a still of it?
Of what?
What you're describing, like Anthony's doing.
I don't have Soundly's video up here, but I could probably get it and play the video. You can see that later in the evening, the lights curve down again. There is a period through the transit is shortly after nightfall and progressing through into evening, where the lights move around. They don't stay in the same sort of
no, that's the point, Miles. They all stay exactly where they are, but for a little shimmering of refraction. Negligible
refraction. And what you've done is you've captured some images here, but this is all quite in that
quite
period
consistent.
It's in that period where it's going wrong, but as the temperature settles down, the light reverts to a nice sort of consistent curve again.
No, it doesn't, Miles.
Sorry, Miles.
Oh, yes.
Sorry, Sleeping Warrior. I just want
Yes,
Miles
please.
to clarify this, not rather than you challenging him on it. Miles, if you tell him you've described that there's a massive curve, and the contentious point is that there's
no, I'm not describing any massive curve at all.
or massive amount of refraction.
No, I haven't ever said massive amount.
No, it was Paul that made that assertion.
And
I'm
even
saying
Paul's making
non-
that.
No, we're
Standard
saying mirages going the other way, going concave.
But the evidence isn't supporting it being non-standard atmospheric conditions, Paul. It looks very standard. There's nothing crazy about what's going on.
What do you mean it looks standard?
Concave
Because
mirage.
there's
The fact that the lights appear to be in a straight line is the evidence that it's non-standard refraction. That is the
That's only
evidence.
your premise is that it's a ball.
It almost went like 100% the other way instead of going curved around down. It's like concave up the whole
Yeah.
other way. Gee,
This
which
is
is
what
not
we had
bizarre.
like an hour-long argument about
And that
yesterday.
has been explained to you.
Yeah, explained, but not supported by the maths or the science. That's not what the
It
science
is
says.
absolutely supported by the maths and the
Do you want to bring the
science.
maths up again,
Right,
Anthony? Because we went
You
through
want to
this
claim
over and over
something
again
different,
yesterday.
you
and-
have to produce something that shows the maths and the science of your claim.
No,
Show me the
no, Miles. We'll stick to the claim that has been made for this experiment and the maths that supports it. And we went through this for an hour yesterday, and we got
We are
nothing.
both making
We got
claims about
Miles.
the
You
same
tell people
thing.
not to interrupt.
The
And now you're
maths
interrupting me.
support our
Miles,
claim.
we went
It
through
does
this
not
for an
support
Miles. You're
Anthony's.
interrupting me. You're being extremely rude. We went through this for an hour yesterday, and what we got was a lot of ad hoc. And now we're getting it again.
It's not ad hoc.
Yes, it is.
No, it isn't. There is
Oh, okay. No, it isn't.
a perfectly accepted explanation for what Anthony has seen. Anthony claimed that the lights could not curve up due to refraction, and I have shown that they can.
That's not what he
That
said
the
at all. He
effect
said the
of
maths
refraction
doesn't support
does
that.
raise
That's not what he
distant
said,
objects
Miles. That's not what he
upwards,
said
not
at all.
downwards.
That's not
Anthony
what he
is
said.
making a claim that this is not that the conditions, atmospheric conditions in that video are standard. I would like him to justify that
He
claim.
has.
How
He's shown
can he
us
claim
pictures of
it is
boats
standard?
hovering above the horizon. That I would call non-standard. There's nothing in that video at all that makes me think, wow, crazy refraction going on here. Nothing.
The fact that the appearance of the lights curves downwards, it then goes more wobbly, and you can do freeze frames where they are straight or curving upwards, and it then settles down to them consistently curving downwards again, says that something has changed in that view.
Would you
And
want
the
to
obvious
tell us
thing
which
that has
frame to
changed
look
is
at,
the transition
Miles?
from day to night and the temperature change.
Well, tell us which
know
frame. Which
causes
frame
refraction.
supports that? Which frame? Tell him. He's got the video up. Tell him where to stop, and we'll go on that.
I can't see the video playing at the moment.
Just click on Anthony's icon, sleeping. It says. If you just click on his icon, it will show you locally in the Hangout.
What I'm seeing
Has Anthony got the video, or has he got still shots from the video?
He's got both. He's just had the video playing a moment ago. I don't know if he's nipped away from his keyboard at the moment. Hopefully he's still
I've got
here.
it ready to play too if Anthony hasn't got it. But if Anthony's
you
got
go
it,
ahead. I'd rather have you do it, Paul, because you're on the other side of the argument.
Sure.
So I'd rather you presented it, if I'm honest.
yeah, okay, I can present it if you
Yes,
like.
please.
Okay,
Please do.
let me get it here. Okay,
Hey.
can you see it now?
Yep.
Can you see that there? Okay, you can see at this point here that it clearly curves down. It's unmistakable that that curves down. I don't think anyone would argue that that curves down at the moment. So what we'll do is we'll play. I'm not sure what the latency here will be like, but we'll see. Okay, so just watch it and you'll see the light will fade.
Where are the lights?
Okay.
I can't see the lights. Where are the lights?
Just wait till it gets dark. The lights will appear when it gets dark.
They're
What you're seeing is
still
the curvature of the
setting up.
ridge, right? They're still setting up.
Yeah,
Right,
actually, no, they have set
now-
up. I can see
Now
the
we
lights.
see the lights, okay? And what you see is you see now that the lights appear to be coming up. Okay, so those end lights appear to be coming up and they appear to be going in a straight line almost now. That's what Anthony is saying, that these ones here appear to be going in a straight line. But this is soon after sunset. This is the period of time when the air temperatures are trying to equalize as the sun has set. Okay, so we continue on, and as we continue on, we'll watch the video and continue on. And what you will see is as the night progresses, the atmospheric refraction settles down, the temperatures equalize, and you will see those lights start to curve back downwards again. Okay, so just keep watching, be patient. Okay, as we go,
They're already curving down.
they are. Okay,
Imagine how much vacuum is out there just waiting to suck us up.
all right, so if I pause it there, I would challenge anybody to put a piece of paper across those lights and tell me that they're straight.
So
Because
how's
that's
that any
not-
different to me cherry picking one where it bends the other way?
That's curving downwards now, because what we see here is later on in the evening. All right, this is way past sunset, It's later on in the evening when the temperatures have had a chance to equalise, and we're starting to see it come back to standard refraction, where we don't see the more extreme effects of that period just after sunset. Okay, so as we keep on playing, it should settle down even more, and the curvature should become even more.
No, it's going back up again.
The sun opened.
I can see that in light, Paul, waving up and down. It's going up as well as down.
Yeah, but here you can see that it's clearly curving.
You do realise that, don't you?
Of course I realise. It's
right.
written on screen, Miles. Don't be pedantic.
Yeah, it's clearly going down.
But it went up as well. I watched it in that video. Go up as well. You just seem to be cherry-picking the ones that support your argument.
Exactly.
Not at all.
Not at all.
No.
Right.
You're trying to argue that it's non-standard.
It's going down there. What we're trying to say, Nathan, is that
actually the angle between the lights and the bridge there is totally different. If you cut that
here
as well, so that means that the water
curves
down. To the solid ground is different.
Right. So as we progress through the evening, here it clearly curves downwards. As we go, I'm just going to click. I'm not going to play it. Okay. So I'm just going forward in small leaps. Okay. So here. This is just after sunset, and you can see that the end ones are up higher. There does appear to be more of a straight line there, right? So I'm just going a little bit forward each time. So a little bit forward. Here it seems to curve up a little bit. We are now just a little bit past sunset, okay? As we go a little bit further on, it'll start to come down. Now you see it start to come down. Okay, so as we go further on, you see it bend further down. All right, I don't know how you can't see that. It's now curving downward.
Back up.
It's the water press.
Right, it comes back up briefly. All right, but it generally curves down. It curves more down in these later pictures than it does curve up. There it's still curving down.
Take a screenshot of that one and put a straight line through it, and let's see how curved.
Oh, let's put a straight line through that one. Definitely, a lovely curve there.
Yeah.
Right, so let's do that.
Yeah, that's a lovely curve. Right.
Let's do that.
That's clearly curved.
So can I just ask a question,
That's absolutely
Paul?
curved.
So what you're saying is we ignore the ones prior to it being flat as a pancake and only take the ones that curve down. Is that what you're saying?
No, that's not what I'm saying at all. I'm saying absolutely take the ones that go straight, because the ones that go straight are the ones that illustrate the non-standard atmospheric refraction conditions at sunset. There is an explanation for those.
We've been joined.
They don't indicate that the Earth is flat. They indicate the non-standard refraction.
No, it's not non-standard refraction.
Before you do that, I just want to introduce...
That's your assertion.
Whoa. Just want to introduce Ranty. Sorry. We've been joined by Ranty. Rant. How you doing, Ranty?
Yeah, not too bad.
Good
Nathan,
to have you here.
Just share my screen, please, pal. Just want to pick Paul up on the screen, the shot he's got on screen. I've very quickly just done a screen cap before he got rid of it. Because I wanted him to do it on paint and put a straight line through it and see what happens. This is the image that Paul's got on his screen right now. I need to make this a little bit... No, I don't really.
Hang on.
There's a straight line going.
Where I am.
Yeah, so you've gone below the second one and below the third one, Anthony, with that line.
Exactly. Now that's...
So if you went straight through those two, then the others would be below the line.
Which one? The first and the second?
Your line is going through the lower half of the second lamp and below the third lamp. Join the center of the first three lamps with a straight line and continue that line onwards.
It goes well
and
above the last
ones
lamp.
are below it.
Right.
Therefore, it's curving downwards.
The seventh one is on it. The sixth one's just touching it.
Nonsense.
That's
No,
going
it's
through
not.
it.
Nonsense.
Clearly see that you can clearly see that the last one is well below your line.
And
So
so
would you
is the
say
one
50?
before
Is
it,
it
and so
15
is the one
feet?
before that.
So
Yes.
basically, what your position is that the effects of refraction are non-standard, therefore they're not negligible, right? So the issue then becomes for the audience to decide is whether this is consistent with negligible standard refraction and therefore being negligible or not. And if you argue, if you honestly argue that this is non-standard and therefore crazy refraction, I don't know how it needs to be drummed into you that it's
No,
clearly
you
not
don't
what we're
need
seeing.
to. You don't need to say that non-standard is crazy refraction.
Right, this is clearly normal. This is clearly normal standard refraction. It's negligible.
clear.
That shot is, yes.
You cannot make that assertion, Anthony, without
define
you knowing
normal.
what
Look at the
temperatures
evidence.
are.
You have to
Right.
literally be deluded to go against what I've just said. If you want to go against that, that's your prerogative, and you can have that opinion.
No.
But I don't think
Okay,
any
Anthony,
sane
Anthony.
person
This year,
will see that this is
year
crazy.
is showing
Anthony.
a curvature downwards. You
No, it's
haven't
not.
shown a straight. It does. You can clearly see that the last one there is below your line.
The only
Can I ask
two
you a
that are below
question?
that
You are
one-
going over the
that
top
one.
of those last three.
The only
You
two
are going over the top of the last three. You're going through the middle of the middle ones. Right? Those
Yeah.
end ones are clearly below the line.
So what happens if I argue that the first two are a little bit too high and it's the other ones that are too low? And it's simply refraction, normal refraction. And anyway, listen, the
Can I
other
ask
thing,
a question?
where's the missing curvature? Because the bottom line is meant to be 36 feet below the first one. That's what we
No,
should be arguing.
No,
No, I
it's
think
not.
it's about 14 feet. I think.
No, it's not.
No, it's not. It's 36 feet.
No,
What, a mile 8 from 5 feet?
not at all.
Well, that ain't even 1 foot.
The camera is 6.5 meters above the height of the lamps.
It doesn't matter. We've got a fixed reference point of the 5 feet above the waterline. The first one should be 36
You
feet
do not have a
above the
level
last one.
instrument taking the image. You have
You
a
don't need any
camera
instrument.
You've
and
got a
above
measure.
the image pointing down at it.
Where's the curve?
Therefore, you will not
This is
see
not-
the same effect.
No, you guys
This
are
is
just
not-
simply you're simply
This is
denying.
not taken along the line of sight.
It
This
doesn't
is
need to be
taken
when you've
from
got fixed
above.
reference.
Does. You don't understand any of this, do you? You really haven't got a clue.
I don't understand how you two can argue in favour of the ball based on the evidence.
Anyway, before you get into a row, we've been joined by Tony.
Because all
First
the
of all, can I
evidence
just say hello
argues for the
to...
ball.
No,
no, it
clearly
doesn't.
not. Miles,
Miles,
bear with
let
me. I
Nathan
just want to
do
say
the
hello to our
introduction.
new guests. We've been joined by Tony. How you doing, Tony? Thanks for letting me know you're real.
Hi guys,
Well,
I'm
you're
sorry,
going to
but
the
I've got to
mic.
leave. So have fun with this, but I think we've knocked it out the park. Cheerio.
Not on the side.
Shut the
And
door on
we've
your way
also
out,
been
Nathan.
joined
I'm gonna
by
leave you guys
Lewis
to it as
Hackett.
well.
La, 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 la,
I
la.
just wanted to
No,
control
no,
you.
no. Stay, Riley. Stay.
How you doing, Lewis? Good to have you here.
Damn.
All right, I'm sharing my screen again. Right, I'm going to go back to where I was on that video. Right, I am actually going to go back. Can you see where I am? Okay, I'm going to step forward slowly. All right, so as we see, it comes up, and I'm slowly going forwards, just a little bit each time, and it comes up. Right, and it comes up. But then as we go on through the night, you clearly see them going back down.
Okay, may I
Waterbrass.
make a point? Have you, when you look at the moon and you look through the atmosphere and you look at the moon and you try to focus on it with a camera or something like that, you know, the edge of it, it seems to wobble in and out, and sometimes it looks like part of the moon's missing and then it comes back and then it goes out and it stretches and comes back, and it's like a wave effect.
That's atmospheric.
Yes, this is exactly what you're seeing on this. Now the moon isn't changing its position. The moon is fixed. It's in its orbit. It's there. It's straight. It's the same as these lights. They're there. They're fixed. It's just that the atmosphere is just waving it slightly. It's not going over a curve. Because when
Well, no, that last bit, you can't make that assertion based on
what
what
I'm
you
saying
see.
is the optics is similar to what you would see when you're looking at the moon, and parts of the moon get missing and then they come back again. It's just the same
Yeah,
thing.
that's-
It's waving
well,
in and out.
You
I mean,
do
I
see
don't-
these lights waving around a little bit, but generally you see them curve as well. They do wave about a little bit in their positions. That's clearly obvious on the video. But generally you see
But they
them
always pass
start
through
off
the center.
as a
They always-
curve. You start off as a curve, it comes up straight, and then it goes back down to a curve.
And then, but it always passes through the
Okay.
middle. It goes through the middle. It goes up, bends up, goes down
What do you-
through the middle.
what passes
down to
through the what
the
what
line.
passes through the middle?
The lights all line up in a
Huh?
straight line.
So
No, they don't.
Yes, they do.
They do not.
Yes, they do.
Right? I'll share my screen again. They do not. This is clearly
Okay.
not lining up in a straight line.
You don't think that what's
You
right.
you would have to be deluded to think that that lines up in a straight line. You can put a piece of paper across those lights, and they are clearly not in a straight line.
Okay, so you're going to say that in
You would have to be
this
geometrically
video-
challenged to know that that's not a straight line. That is definitely not a straight line.
So this is sound. This at the end of his video, he has a screen capture, basically, of the most curve that you could possibly get on that image, because he leaves that particular image up for around about 20 seconds. Now, you know what sound is like for frauding and fudging stuff. So obviously,
no, this is just a personal attack. This is a personal attack. It has nothing to do with what's being presented here.
I have seen the video at least a dozen times.
No.
I have seen it.
You assert that Soundly is a fraud is a personal attack and nothing
Right,
but
yeah, let him make the personal attack.
No, let me finish what I'm going to say. Is that screenshot is not a representation of the entire video. It is the one point in the video where it appears that there is the most kind of curvature on one frame. Throughout the rest of the video, it is either straighter or curving up or bending down ever so slightly. That is the best image he could have got for the video, from the video.
Oh, well, come, Ranty. Come. I've seen the whole
I've
video. It never curves up once in Soundly. It never curves up once and never even comes close to curving up once.
Anthony, are you there? Could you show him the image?
I'm just going to make a quick introduction to Mr. Grim V. How you doing, Grim? Good to have you here.
Thanks, appreciate it.
Yeah, Anthony ran away as soon as I came here because, you know, I destroy him every time.
Oh, I see.
The point also to be made is this isn't actually Soundly results. This is a time lapse of the experiment taken from well above the experiment. This isn't even the
along the
results.
road. I go forever.
Okay.
You can see the land in the
Always
background.
takes the words out of my mouth and then makes them better. I might as well just be quiet.
Okay. So Soundly has yet to actually put up the video of his results.
You're saying that the lights never ever curl up at the end on the video?
Huh?
You're saying that the lights never curve up at the end on the video?
I'm not saying anything. Soundly hasn't put his results up yet.
Okay.
We have yet to see his final results.
Yeah, everybody's seen the video though.
This is a time lapse taken from above the experiment. The actual observations of the experiment are going to be taken down at the level of those lights. And we are going to be looking along the level of those lights. That's when you'll see them dropping down or whatever they do. Here, we can't make that much judgment about what we see here. This is just an overall, and Soundly made that quite clear that this was nothing more than a time lapse of the proceedings of the day. This is not the experiment.
Still useful. You can still refer to it.
Yeah, it's still really useful.
Right.
Yeah,
that's right. All right, but make no mistake. This is not the experimental results. Okay.
Let's try and take a more simple approach. Does light in general travel in straight lines? And could you, so when I say that, I understand that there's a little bit of bending that goes on as it travels through a medium, depending on the density of that medium relative to the other mediums that it travels through. So, you know, cool, wet air or cool, dry air compared to hot, moist air. There's a little bit of a difference that it'll travel through. But would you accept, Ranty and Nathan and any flat earthers present, would you accept that light in general would travel in a straight line?
When it's not subject to any kind of atmospherics?
No, even when it is, it's not changing so much that you could say see around a corner. At no point will light change so much that you can see outside of that's why it's called the line of sight, is because the light is traveling in a straight line, more or less.
Right, when you spearfishing,
it's not.
So when you're spearfishing through water, obviously the light's changing its path as you look through the water.
But if you're in the water too, then the light isn't changing for you. It only changes when you're looking up out of the water. You get this effect where you can see a wider field of view when you look up from underneath water. But that wider field of view is condensed into a narrow area. So yes, there is a bending effect that occurs when you change, when the light is changing medium. But if you're in the same medium, that effect isn't really noticed. And
no matter how much that changes, so if you're looking up out of water from underneath the surface at a pool, no matter how much there is, somebody who's obscured by the edge of the pool is not going to be visible, no matter what. If you come up above the water and the edge is still there, you're not going to be able to see the person.
I mean, I agree with you, but what I'm trying to say is that when we've spent literally, this is now the second show when we've dissected up the minutiae of refraction, you're now trying to get us to say it travels in a straight line, and obviously that's going to be a difficult thing to agree to, isn't it?
Well, it doesn't. Yeah, exactly, and that's the whole point. The refraction is minute. It's extraordinarily minute.
Okay, negligible even.
Right, I would say negligible even. I would be very content to say that refraction is very negligible. And if you look over land, you can make it even more negligible because there is no significant temperature difference between the layer of air over the ground than above.
But the physicist on the panel is telling us otherwise. He's saying that we've got extreme circumstances, and you're saying completely opposite to the physicist. So
no, well, I'm not saying extreme. I'm saying non-standard.
Yeah, extreme just means non-standard, and it refers to the peaks and valleys on a graph rather than the middle, the average.
Yeah,
that's what extreme
you're saying
means.
it
It's not calling something extreme in terms of data is hardly ever actually an extreme thing.
You're saying it's not non-standard, as he phrases it. In other words, negligible. That's what you're saying, and he's disagreeing with that. He has a completely different stance.
He's not disagreeing with it, all right? You're using different words, and you're rephrasing what he's saying, which doesn't need to be done.
I'm not rephrasing it. I've used his exact words.
Well, you use the word negligible rather than the extreme cases, which he's rephrased to non-standard because you rephrased it to negligible, which it's not. It's not negligible if you're trying to talk about what refraction's doing. But if we go to the main simple point, which is that light in general travels in a straight line, can we accept that?
Clearly not. I've just gone over this with you.
So how much do you think light's curving? Can you at any point see around a corner?
I think that's what Lewis is trying to say. He's trying to say
when does standard
you
turn
might
into
take a 90-degree angle.
Well, in effect, this is what the ballers would have you say, is that you can see behind the curve because the light bends. So
no,
in
you
effect,
cannot see behind the curve.
Yeah, this is what they would say.
During a Fata Morgana.
Well, I'm here. I'm one of these they here now, and that's not what I'm saying. So clearly, that you're misrepresenting me.
I'm also one of those they here now, and I do say that during a Fata Morgana mirage, the reason we are seeing what we're seeing is because of refraction, that it is over the horizon. So I'm not sure. Well, if we're splitting hairs here because we both agree.
Well, these mirages don't occur everywhere, and something that does occur everywhere is the horizon itself. And no matter how much you zoom in on that horizon, you're not going to see past it.
So is a mirage standard then? Would you class a mirage as something that's standard?
Mirages are not standard.
On the conditions of the medium, that the different you have to have hot and cold, which is or more or less pressure or particulates. I don't know how to.
I'm trying to conflate this, but I just want to conflate it for the audience room. So what I'm trying to establish is what is and isn't non-standard. If Fata Morgana isn't non-standard, then presumably what we saw on screen is standard.
If something isn't non-standard, then just call it standard. Yeah, just call it standard at that point.
I didn't use that term. I used the term negligible, and then that was changed by Paul. Sorry.
That's fine. So
you're telling me I'm paraphrasing when I'm using exact words, and then when I'm using exact words, you're telling me that's not acceptable use of words.
Mirages and refraction are not standard things. They are the exceptions.
So the standard would be what?
That light's traveling in a straight line, resulting in a horizon that no matter how much you zoom in, you cannot see past it.
Well, that's not what we see, though, is it? That's not what's being.
No, that is absolutely what we see. Go
That's where I agree.
go anywhere on the planet you like and zoom in on the horizon, and at no point are you going to be able to see past it.
By
Correct.
zooming in.
If
By
the
zooming
Earth
in.
were flat, there is no limit to how far you should be able to see. Things should constantly be brought into your field of view out of the vanishing point.
But that's what
Constantly.
it is the vanishing
That
point.
effect should never end. But it does. It does end. It quite clearly ends, and there's
see
a point
forever.
on the horizon. As you zoom in on the horizon, objects get bigger and bigger, but they were already visible. They were already within the line of sight.
I still just need a bit of clarity. I'm confused about
confused
what
as well.
isn't standard and
Light
what
doesn't
is
travel
standard
forever in a
refraction.
medium.
What is standard? You tell me what's standard.
It doesn't
So
matter.
far-
It doesn't matter what standard.
That's what the
Extreme
discussion
cases,
is.
no extreme cases. Look at the horizon. And no matter how long you look at that horizon, it might change a little tiny bit because of refraction. Might change a little tiny bit because of mirages, your various types of mirages. Those are the extreme cases. But you're never going to see substantial distances past the horizon.
Sure,
I'm talking about
I
ground.
understand what you're saying,
You're never
but
going to see the ground
we're talking
past the
specifically.
horizon. You can see the ground up to the horizon, but you can't see the
Yeah, you
ground
keep saying the same
past the
thing.
horizon.
You're just repeating
And
yourself.
that is the case no matter where you go
Yeah, you
on
said
the
that
earth,
as
and
well.
that's
I heard
because
that. It's
the
the third
ground
time I've heard
behind the
it.
horizon
Maybe you want to say it a
is
fourth time. Louis. Do you want to say it a fourth
relative
time?
to
Maybe,
you.
maybe everyone's deaf. Maybe we need it 5 times.
One more
Maybe
time.
you repeat it again, Louis.
Repeat what?
The same thing that you've just said 3 times.
Well, I haven't
Try
gotten a response to it yet.
Well, that's because
Because we
the
don't know what
question
you're
was
saying.
about
I'll-
what is
I'll
about
respond.
Durante's
You're
cocktail
absolutely
point.
right.
All right. I'll say it again.
No. That was sarcastic, Louis. For the love of God, please
All right.
don't.
So why did you ask me to do it? Why are you being sarcastic?
To
with me,
point out
Nathan?
that you've said it 3 times, and I've pointed that out
Yeah,
to you,
so
and you
why
just said
are
it a
you, why
fourth
are you
time.
being rude?
Because my question was simple. I'm trying to establish what is
Uh-huh.
standard about refraction. Where does that parameter of being standard lie, and what sits outside of that?
Well, it's about the relativity. So if something is not, if you look up or at something near to you that's not being refracted substantially, then relative to those observations where the refraction is much smaller, it's non-standard when you look a long distance and you see lots of refraction. But if you're always looking long distance and there's refraction everywhere, then you're going to find standard refraction and extreme cases of refraction in those observations. So it's all about relative to what you're looking at.
And where can I find
the
that
types
defined?
of observations
where can
that
I
you're
find that
making.
written down and defined, and with an equation or something that I can tie to that? Because that just sounds like
An
an
equation? No,
anything.
Nathan. You need to go back to school if you're asking these questions.
Well, hold on. I have something
Nathan,
for you,
Nathan.
Nathan. I posted a link, Nathan.
Yes, it's in the
You-
side chat, Nathan.
You might
There's
want
an
to read
article
that.
there. Yeah.
That's what Riley is reading from, where he got his negligible from. I would encourage you to read the entirety of the paper, and especially section 3 that Riley is cherry picking negligible from. Get a lot of context there, and you see that what he is claiming is not actually what the paper is conveying. And one more quick point, if I might, Nathan. You accused me of not answering a question, just giving ad hom or ad hoc. How do you know what I said in the last debate when you cut away while I was speaking to go do your links, as you call them? How do you know what I said to Riley, what I tried to bring up to you guys, and in talking about, look, we need to work on up and down and get that in context. Which way are you looking at this? From the perspective of the observer or from the perspective of the source, like with in the direction of propagation? Now, I tried to talk about that. I was stumped over and accused of not answering the question.
Well, you'd have both
and you
been
didn't
muted.
even listen to me.
When I did my links, you would have both been muted, and Anthony Riley would have been on Skype, so you wouldn't have had any line of communication with him whatsoever while I did my links.
So how do you know what I answered and what I did not?
You just asked me what you said to Riley, and I'm telling you categorically that while I did my links, you had no connection with Riley. Fact.
And that's my point. How do you know? I was speaking and I answered questions.
So I know
tried
what
to
you said
talk
to him.
about
What
it.
you said to him was nothing. During
You don't know what I said.
What, to Riley,
I was
specifically
not
to
heard.
Anthony, which is what you accused me of. Well, how do you know what I said to Anthony? Well, I know what you said to him because I control the desk, and what you said to him was nothing.
Yeah, you didn't answer the question I asked you.
All right, that's fine. Let's
Just to get that clear, Curved. Is that clear, Curved? What you said to him, just to answer your question,
let's start
was
over again today.
nothing.
It's really important for us to not get mad at these people.
I'm not getting mad.
Right?
I'm just pointing out that what he said to Anthony during my link was precisely.
I don't care if
nothing.
you get mad, Nathan. I'm talking about Curved and us, the people who are objectively correct. It's important for us to not get mad.
Can we go back to the paper? Let's deal with the point that Curved brought up.
Just want to rub his head sometimes. Good job, buddy.
Let's go to the paper, the part that Curved. If you want to talk us through the point that you want to make so that Nathan can understand it, and then let me respond with regards to why this is contradictory.
Read section 3.
This ought to be great.
Do you want to pull it up, Nathan?
Yeah, sure.
Can I say one thing before? It's going to be 10 seconds. Could it be possible that Paul, a man that's been doing this his whole life, explained it properly enough to where other people that have done it can understand it, but you who have not been studying this your whole life professionally may not understand what he's saying?
Yeah, of course.
Absolutely.
I like that.
But
like
we're
that
only based on we're only allowed to go with what your science tells us. So if we find points in your science that contradicts itself, is it not normal for us to point it and say how?
But I think your contradictions aren't really contradictions.
Right. So let's deal with the point. Curve's brought up section 3, and we'll deal with it. So, but Nathan,
I think the word science is misused a lot by flat earthers. It's interpretation.
Yeah, so is evidence and belief.
Data. Interpretations of data can vary. Science is science.
Yeah, and
Science is there's not a war against science like what's his stupid face says. A war against science. It's a war against the improper interpretations would be a better way to word that. Because against science, really? I mean,
and I didn't say that as disrespectful or anything, because there's many things I don't understand, and I think I grasp it, and I think I have it down, but then like it's explained, and it takes me a little bit longer to get. But so I'm on the same wavelength as most people too. Sometimes when it comes to that, so I'm talking shit to myself too. So
Section 3, the simulation process. This section describes the underlying physics of our simulation as well as 3 main building blocks of the algorithm. An accurate description of the exact trajectory of light as it traverses the atmosphere based on the laws of physics. The resulting differential equation will in turn need a robust, efficient numerical resolution method in order to keep rendering times within reasonable limits. A model of the atmosphere based on well-established standards with a precise description of the index of refraction as a function of wavelength. A tool to de-standardize the atmosphere in order to recreate the necessary conditions for the effects to occur. This has to be based on real data when available, borrowed from meteorological stations and scientific literature. For the functions used, resultant values must be compared with actual measured data. All right.
Right. Can I just focus on one particular part? Look at the part where it says underneath the equation, I think it's paragraph 2. It reads, this phenomenon is known as refraction. Can you find that paragraph and just show it on screen? Starts with this phenomenon is known as refraction.
I don't have the ability to scroll around.
No, Nathan's on it. Although I think he's left. Are you back? Are you here, Nathan?
I'm just keeping an eye on the Hangout at the same time. Sorry. Where do you want me to scroll down to?
Just scroll up a little bit on that page that you're on there. Just a little. There. Stop. Can you see that? Could somebody just read that paragraph where it says this phenomenon is known as refraction? All right, I'll read it. This phenomenon is known as refraction, and it is traditionally accounted for in any ray tracer. It shows how light gets bent towards the medium with the greater index of refraction. I don't think anybody's got a problem with that bit. However,
let's read the paragraph above it, because that paragraph
The medium on the bottom
is talking about refraction is going to be described in the paragraph above. So we should read that one.
well, we're talking about. Feel free, but we're going to come back to this point. So if you want to do that, you read that, and then we'll come back to him because I'm setting the context by reading this paragraph. It was the next paragraph
you just read is the reason why you can see around the curve during those extreme.
Hang on, I was setting the context for the next paragraph.
Thank you for reading it.
Focal point is.
But that very last thing you just read is exactly why we see around the curve during those extreme conditions.
Nobody disagrees with that. The next bit is
okay. All right, cool.
The next paragraph.
That's the first time I've ever heard a flat earther say that they don't disagree with that.
Listen, guys, the next paragraph reads, Snell's law is formulated considering two homogeneous media through which light travels in a straight path. Now, that's the sentence I want to focus on. Okay, Nath. So remember, it says Snell's law is formulated considering two homogeneous media. Okay. Nathan, would you share my screen, please? I'd now like to present.
Remember, homogeneous means identical.
I know. So
just for anybody else who might not know,
Nathan, would you just share my screen, please?
Yep, you're all up.
And now I'm going to copy this and drop this in the side chat for the benefit of everybody on the panel. And I'll drop it in the side. Oh, I can't because I've not got a link. But right, the paper I'm now reading from is another MIT report. And in this particular report, it says on page 4, the mathematics of light trajectory, it says, it is well known that the Earth's atmosphere is not homogeneous. Yet in the other paper, it says, Snell's law is formulated considering two homogeneous media. So on one paper, it says two homogeneous media for Snell's law, but on the other paper, it says, it is well known that the Earth's atmosphere is not homogeneous. So can somebody
but it's also yes.
Whoa! Can somebody?
No, you whoa!
No,
you whoa!
Paper
I'm going to answer.
And the atmosphere is non-homogeneous, but the other paper applies Snell's law.
Presenting the whole thing right now. There's your problem. Stop.
I know where Anthony's going with this. He's going to try and assert that Snell's law doesn't apply in the atmosphere, and that's absolutely incorrect.
So, Paul, you're the right
reason.
Anthony,
the reason it doesn't apply, or the reason
every time you've
okay
all over me, I'm gonna have to take it this time. All right, that what you're trying to do there is you're trying to imply that there are that there are no homogeneous points between two areas on Earth, which is an invalid statement to make. The entire Earth is not homogeneous, but there are homogeneous points between 2 points that you can observe, and I think that's what you're trying to. That's what you're trying to dismiss right now by using trickery. Right, I'm not gish galloping. I am dancing directly on the point.
Nathan, let me speak to Paul. Right, Paul.
Nathan, why don't you just you
make your point, Anthony, and I'll refute it.
Right, let's have a conversation with Paul. One paper says, the one that Curve is citing says that Snell's law is formulated considering two homogeneous media, but another paper from MIT says it is well known that the Earth's atmosphere is not homogeneous. Why is there a contradiction in two MIT papers talking about the light trajectory?
There's no contradiction there whatsoever. Can I just answer this? There is absolutely no contradiction there whatsoever. Okay, Snell's law is a law that is used to define the mathematical relationships of refraction. The principle of refraction remains the same in both situations. The only difference is that when we use Snell's law, we are looking at a distinct boundary between two entirely different media. And we get a very sharp change in the direction of the light as it passes from one medium into another. That's what Snell's law. It's a mathematical relationship that relates how light bends when it goes through into a different media. Okay, but the principle of refraction still applies even if you go through a non-homogeneous media. You still have light bending towards the normal when it goes into a slightly more dense part of the medium, and it keeps bending towards the normal as it goes into more and more dense parts. Instead of being bent over a very short distance of a hard boundary, the light is bent over a longer distance through a gradually changing medium.
But the thing
That's what is happening there. No, the thing is that Snell's law still applies. It just applies in small increments over a larger distance.
But only
that's what's happening in a non-homogeneous media. There is no contradiction here whatsoever.
There is. It's in black and white, and you can't get it out of it.
There is no contradiction.
Homogeneous media. But it's well known that the Earth's atmosphere is not homogeneous.
It is. So it is well known. It is well known. Anthony, it's
The
extremely
principle
well
of
known.
refraction still- yeah. The
No, it's
principle of
what it's
refraction
very,
still
look,
applies.
Anthony. Let me try and put it in words that you might understand. It's not that you're looking through the entirety of the Earth's atmosphere when you make observations here on the ground.
Do you guys understand?
If you were, you'd be looking through multiple non-homogeneous.
Right. Do you understand what this sentence means, ballers? It's well known that the Earth's atmosphere is
I
not
understand that very
homogeneous.
much. I understand that very much.
What it means.
But
you don't.
But there are homogeneous layers. There are parts of the Earth's atmosphere that are homogeneous. The entirety of it, the entirety of it is not homogeneous.
It's well known, Lewis, that the Earth's atmosphere is not homogeneous.
Absolutely. But it's even more well known that parts of it are. That is extremely
It's more well known, according
it's
to
the
Lewis.
It's the entirety of the atmosphere that's not
Dude,
homogeneous.
you got a citation for that, Lewis? Can you provide a citation?
I'm wondering if you passed first grade English.
I know.
Can you provide a citation for that?
I'd like to read it right here.
Not homogeneous.
Do you have a
Oh,
citation?
I understand that. You need to stop getting. Did you win your court case, by the way? How did your understanding of the English language help you in court?
Listen, I am in the Earth's atmosphere right now. The points between my hands are at the same pressure and the same moisture and the same barometer. Everything is the same. The medium is the same. So here is a point right now that you can see where the medium is the same. Between 2 points.
It's well known that the Earth's atmosphere is not homogeneous.
Now, from here to China, it's not.
Right.
But from here to here, it is.
No,
So
that's not what it says. It's well known that the Earth's atmosphere is not homogeneous.
As a whole.
Yeah. Why don't you read
It doesn't
the
say
next
that.
part?
Has anybody got a citation that disproves this MIT paper or not?
Why don't Anthony read the next part? Read the next part in this paper here on the right.
Yeah, this is where it all goes wrong for you guys.
Keep
because it
reading.
says
Keep reading.
When
didn't go wrong
traveling.
last time you said that.
No.
I don't fear you. Go.
Well, you should fear the truth, though, shouldn't you? When traveling in the atmosphere.
I'm on the truth.
Truth's on our side.
Let me
Why
get
would I
the link.
fear something that I'm telling you right now?
Let's just hear it read through.
I'll have to get the actual file open. Give me a sec because I don't know where
You
it's
say the
gone.
silliest things, don't you?
Wow.
Well,
Can I read the next part of the paper, the MIT paper?
Yes,
Sure.
please.
Okay.
Because I was just
Where
going.
it says Snell's law is formulated considering two homogeneous media through which light travels in a straight path. But all media are inhomogeneous at some degree, with their different properties in varying from point to point. And the atmosphere, of course, is no exception. When the medium is inhomogeneous and the index of refraction changes continuously from point to point, the trajectory of light is affected at each differential step, not just at the boundaries between two media. The final result of this differential change is a curved path that distorts the normal view of a real scene.
Yeah.
But the path cannot be calculated by traditional ray tracing.
So the reality
when you use Snell's law, that is called traditional ray tracing. That illustrates the principle.
No, it's not at all. Snell's law. No, that's not what.
I gotta run. I have a busy day ahead of me. But
I know that.
Hey, Lewis.
To summarize, you gotta stay very calm with Anthony. If he brings something up, you have to chase him all the way to where he got it from, and then go through it more thoroughly because he doesn't understand it. And when you want to accuse him of lying, don't.
Lewis, you need to change
Just
your t-shirt.
focus on how he's wrong. Don't accuse him of lying. That's a distraction. And stay calm. Have a great day, guys.
Later.
Thanks, Louis.
Have a
I'd
shower.
like to point out that what Paul just read is the paragraph previous to Riley's negligible.
On which paper? Your paper or my paper?
The one that's all marked in yellow on yours, Riley.
Okay, so you've
the one where you got negligible from. Paul was reading from the paragraph previous to that paragraph you got that from.
But the problem is, they both papers contradict.
Pay attention to what it says.
The problem is, Curved, both papers contradict themselves, and we're supposed to work it out.
There's no contradiction.
You don't understand.
There. The people that understand it, there is no contradiction there.
No. It is well known that the Earth's atmosphere is not homogeneous. That's not difficult for a fifth grader to understand.
Amen. We know that.
We know that.
Snell's law being calculated based on two homogeneous media.
Anthony, is a square
like
or rectangle?
Water and glass, water and air, glass and air.
Yeah. They're two homogeneous media.
Square is a rectangle, right, Anthony?
Yes. But the Earth's atmosphere is not one of them. So why is
Riley
it being
clearly
calculated
states
for?
that different layers of the atmosphere with different indices of refraction, with different indices of refraction are going to bend the light in the air.
Yeah,
in the air.
But it says
When you have a golf ball sized consciousness, you have a golf ball sized view of the world.
right. I obviously I'm never going to get you guys to see what it says in black and white that's right under your nose. It's directly contradicting itself.
Are you crazy?
For
no,
real,
I'm just
like I don't get
applying
it.
what it says. I'm doing what you guys tell us to do, a bit of science, and I'm going finding the science,
You're not
and it
using
contradicts
your brain
itself.
when you read those words.
It contradicts itself.
You're not just words. The words have meaning.
information.
It does contradict itself. Paul, how can you argue with any honesty whatsoever in your body that these are not contradictory? It is well
They
known
are
that
not
the Earth's atmosphere
contradictory.
is not
They are
homogeneous.
not contradictory. One is referring to a very distinct boundary change. Okay, that's the part where Snell's law comes in, because you have a distinct boundary change. You can define, listen, Anthony, you can define the angles of incidence and the angle of refraction clearly in those situations. You can measure
We
them.
both know that
They are well, listen, please. They are well defined.
No,
That's
no.
how Snell's law works. Let me finish.
No, because you're lying.
They are well defined.
You're telling
No,
lies.
I am not lying. Do you
Ah.
understand how
It
Snell's
does
law
not,
works?
Anthony.
Yes.
What is Snell's law, Anthony?
It's where the light bends into the denser material, making it
What
bend.
is Snell's law?
It's
What
where the
is
light
Snell's law?
bends. Where the light
No.
bends into the other.
Give me the mathematical equation. What is Snell's law?
It's easier to show it as an illustration because the mathematical equation nobody understands. Right? Am I sharing my screen? At the
Someone had to understand it to make it, right? And then there's people that understand that use that. So what do you mean no one
it
understands?
doesn't apply because the atmosphere is not homogeneous.
It's just a guess, Tony. Nobody
No,
understands.
it's called Gish.
I know exactly. You just throw it in the air and see what falls.
Yeah.
No, it's called applying your science against your model based on your evidence and it not doing what you guys think it does.
Well, I think this is pretty much over. I mean, like each side know, I mean, we can't go any further. We've done everything we can do, I think, pretty much, and we just let the crowd, the comment section.
So this is Snell's law. It requires a change in medium. The light will travel into the denser material and it will slow down. That's the application of Snell's law. But in the atmosphere, there is no change in medium.
Right. Can you keep that picture up, please? And I want to explain. All right. Okay. Can you stop? I hang on. I've just got to get it so it stops flashing. Okay. Okay. See that picture there with the blue underneath and the white on top with the box that reads Snell's law equals N1 sine theta 1 equals N2 sine theta 2. You've got that one?
Yeah, that's the one.
Yep. See up above that boundary where it's got the ray going out and it's got that angle theta 2 in there.
Yeah.
That's called the angle of refraction.
Yes.
Underneath
it's called
is
the angle of incidence. Yes.
Yeah.
So what? It doesn't apply.
That mathematical relationship directly links those two angles of incidence and refraction with the refractive indices of those two medium. That is how Snell's law works when you have a very distinct boundary change. What would happen now, Anthony, do you think? It keeps on disappearing.
It's because I'm just about to counter you.
I want that picture back. Okay. What do you think would happen? What do you think would happen with that light bending? Instead of that having a very sharp boundary between blue and white, what if we smeared that out so that it was a gradual change from blue to white? So it was a gradual transition from blue to white. So it was a gradual transition from blue to white. The light wouldn't bend sharply. It would curve around.
The answer to your question is then it would not be a homogeneous media and it wouldn't apply.
That's right.
It requires a change in medium.
That's correct. It is a change in medium. It's just not a sharp boundary change. It is still a change in medium.
There is no change.
It is. It is a change in medium. It's just not a sharp change.
No, that's not true. There's no change in medium because we're still in terrestrial air.
Right. So we've still got air and water. I'm saying, what if this water at the bottom was a different layer of air, a more dense layer of air?
When we're looking across the atmosphere. That's the point.
But that's what happens. What I'm saying is, imagine that boundary was now not distinct and sharp. If that boundary was not distinct and sharp, you wouldn't get a sharp change in angle at that point. What you would get instead is a gradual bending around over
Problem
that
is-
distance that the medium changes.
Without
That is what happens in non-homogeneous media.
no,
Can I
but
read
Snell's
this again from Anthony's source? When the
Snell's law
medium
doesn't
is
apply.
inhomogeneous and the index of refraction changes continuously from point to point, the trajectory of light is affected at each differential step, not just at the boundaries between two media. The final result of this differential change is a curved path that distorts the normal view of a real scene.
Yeah.
You want me to go on, Anthony?
Yeah, go to the
perfect right there.
paragraph previous to your negligible. They're
Yes, there you go.
contrasting
There you go.
extreme refraction.
There you
with
go.
this.
Yes, right. So that's you've just said it there. It's negligible. So all this
Appears-
bendy light stuff that you're
negligible
talking about is
context there.
negligible.
I'm giving you the context of the negligible there, G.
Yeah, and it poos all over
Listen.
your argument, Curve.
Stop talking
He doesn't
and
get it.
listen.
It poos all over your argument, boys.
You're the only one who doesn't understand at this
For
point.
real.
No,
No, there's others.
context.
There are people like Riley that believe him and think that he is correct.
I don't
Yeah,
believe that.
straight.
God knows why.
I do not believe that.
The
Remember,
context
Fog into
is
regular sky. How about
negligible.
that?
shadow from the moon goes through
Negligible.
the sun to project the image of the moon on the face of the sun. That's the
Right, so let's conclude this, right? Curve brought up the article and suggested that we read the whole thing. So we pretty much read the point that he asked us to read in paragraph 3. I then showed you a contradictory MIT paper saying the absolute opposite, but the context
It's
of
not
both of them
contradictory.
is that it's negligible and it isn't worth
It's not
discussing.
contradictory.
It
They
wasn't.
are
saying that.
contradictory. They're
It
against-
is
That's why
not
Ranty jumped off.
contradictory.
And even let's just say that they're not contradictory, right? And for some reason you interpret the words the opposite of what they say, which is what you ballers do a lot. You redefine terms a lot. But let's say
No,
that
that's
they were.
you.
Let's say that
Riley,
they were. Not
That's just as contradictory as saying a square is a rectangle, but a rectangle isn't a square.
we're still left with the argument that it's all negligible. in
Hello,
any
are
event.
you listening to this?
No, I'm not listening to you at all. We're still left with negligible.
It's sort of
So
important.
small
Like,
or
hey,
unimportant.
Riley, you got a
as
booger
not
on
to
your
be worth
face, and you're
considering.
going out in public. We're just trying to help you out here. Hey, buddy.
And also,
Fraction is negligible. That
On
means
the other side.
all right,
boys.
here you go. I'm going to read the entirety of this sentence for some context here.
Don't forget to use your
On-
finger in between the words curved. It helps you split the words up.
Under standard circumstances, the effects are negligible.
Yes.
It is under non-standard circumstances when we really see some amazing atmospheric phenomena.
So then
Probably
when we
the
go back
best
to
known as the
sound,
Imperial Mirage, blah blah blah.
So there are sorry to interrupt, guys. This is exactly the point that I tried to come in and try and tie Lewis Hackett down to, which is what is and isn't standard.
hang on. Then you got to get to the question of, well, how when you described what you just said, then how amazing how is
I got that.
how amazing is
I
what
agree.
we're looking at here, boys?
Standard.
Exactly.
Can I
exactly.
answer? Can I
Yeah,
answer, Nathan?
The lack of the big giant change in medium would be the standard, obviously, because that would be what without take out the control. How what's the shape of the Earth?
Wow,
Take the
look at
control-
how amazing
make
that
a control,
mirage is.
take
there,
out the
Nathan.
atmosphere, right?
Right.
And so that would be your standard, right? Your standard
Sorry-
would be the
sorry,
Wow.
Kurt.
average
Go ahead,
atmospheric
Kurt.
pressure.
I'm blinded by the non-standard refraction there, Nathan. You?
No, then Curve's got an explanation. Let's hear it.
Well, the standard would be the least change in medium possible.
I'm sorry, I couldn't hear
That would be
Nathan.
the closest to a control, right? That you can get. So we call that the standard, since that would be, unless it's standard in a different location where the standard would be the Mirage, because that location would have those conditions, that climate, like on a
But is there any evidence to
more
support
than
this
average
being
basis. Yes, there's
non-standard?
evidence from all over the globe.
No, in
Is
this
there any
photo,
evidence
Grim.
to support this being non-standard refraction, boys? Or is it as
Yeah, you
negligible as it
define-
looks?
This is the main question. We're back to the beginning. Thank God.
Right. Well, yeah. What's the barometric pressure? What's the temperature of the water? What's the temperature of the air?
Well, they're
You
all
know,
the
those
factors.
things
Put that in that
See,
equation.
Grim,
So you're asking me to make a
know.
scientific
Grim,
evaluation of a thing that has no data.
Grim,
point.
what you've just said then is
you're not
exactly
realizing-
what, Grim, what you've just said then is exactly what this calculation claims is based on in here, which is there the pressure, the temperature, the density, the viscosity. But
I know.
as we can clearly see, it's actually based on the arc of a circle, so it's got nothing to do with calculation.
No. It has everything to do with it. The
Well, does it
7-6
apply?
approximation is a way to incorporate the conditions described in the international standard atmosphere.
And when we calculate for the conditions in the international standard
you call
atmosphere,
it an atmosphere,
there's no radian. There's no radius.
Oh my, Riley, this is how they account for it.
I feel bad for you.
It might be, but it doesn't exist in real world because it's based on
No. It does exist.
Based on
it does exist. And again, this is how they arrive at the 7.6 calculation for the approximation for the conditions defined as international standard atmosphere. You're not going to see 7.6 represented in this article on Wiki that is just describing international standard atmosphere mathematical model.
Okay.
So,
you guys want to know? You guys want to know what a non-standard atmosphere is? Okay. So I'm going to share my screen again, yet again, and go through a little bit. You're not going to understand all this because it is highly technical. However, I am going to go
Please
through
don't
it.
interrupt him.
Okay.
Let's
just look at this part here, right? You're going to have to bear with me for about 5 minutes, okay? So this part here, from 3.2 onwards, the atmosphere. Let's read a little bit of this, okay? To model the atmosphere, we start with the 1976 US Standard Atmosphere,
which is
and
what
you
I
can
was
find out about that in
Anthony, can you just give him
citation
5
20,
minutes,
right?
please?
It is
Just
the
let him get
average
through
of
it.
pressure and temperature for the various altitudes which make up the ideal steady state profile.
Right?
The values select. You really need to bear with me here, Anthony.
Silence yourself.
The values selected in 1976 come from slight modifications of the values adopted in 1962. Figure 2 shows the temperature and pressure values for the first 34 kilometres of standard atmosphere. From the values of the standard atmosphere, intermediate values are obtained by interpolation. As it can be seen, temperature decreases with height at an approximate rate of 0.6 degrees Celsius per 100 metres. Under these conditions, air is perfectly stable and no unusual effect takes place. Starting with the standard values, we seek to obtain a profile of the index of refraction for any arbitrary atmosphere and as a function of wavelength in order to render the desired effects. We first need to obtain the density profile for which we take the temperature and pressure data and apply the perfect gas law. What they do here is they go through a little bit of information. All right. I'm going to skip that paragraph there because it's technical and not really relevant.
None of which is the radius.
We now need an expression for the index of refraction in a medium as a function of wavelength for low density media, such as air. And they go through a little bit more technical stuff, right? Bear with me. And they've got some graphs here for how the temperature varies with height in the atmosphere and other stuff, okay? What they then do is they go through, all this bit here is just going on, and they're talking about standard atmosphere and values. But what they actually do, at this point, we have on one hand density as a function of height, and on the other hand, the index of refraction, n, as a function of wavelength. To obtain n for any height and any wavelength, we should combine both equations, and they do that. So they go ahead and they combine both equations, right? And they get an expression for that variation, okay? As they go down through this article, what they do, now, this part here is the most important part. A description of a standard atmosphere is a necessary starting point as it ensures that the simulation is based on actual data. The next step in the simulation process is to de-standardize the atmosphere, recreating the conditions necessary for the effects to occur. To do that, we have developed the APM, which enables us to set different temperature and pressure profiles at different heights. From there, the new profile for the index of refraction is obtained. So what they do to de-standardize the atmosphere is they take experimental data collected from measurements in atmospheres and they apply those changes to the standard atmosphere and they work out what the index of refraction is at each and every point in the atmosphere. This is what makes this paper so good because they can know what the refractive index is at each point.
Yeah.
Okay.
I'm with you.
So they can model.
I agree with you.
Okay.
Oh, good.
So that's how they de-standardize the atmosphere. They apply actual data.
But how does that
Okay.
relate to the radius calculation that Mick West cites that you guys all worship?
Okay, the radius calculation there is an average. It is an approximation to a standard atmosphere.
No,
It summarizes a
calculation.
whole heap.
It's a calculation
Exactly. It's
based
a
on a curve
calculation.
going down.
It's a calculation that summarizes a whole heap of stuff into one calculation. All of this stuff on that paper is summarized into that standard calculation.
Yeah, and it all goes down, Paul. It never goes up.
Well,
What?
no.
That's not true.
Can we see the calculation
about up
again?
and
Can you
down.
just
That is
bring it
true
up
on your
again,
maths.
please? Can you bring it up
Because
again?
that calculation is for, is for, and don't you read it, standard refraction.
Yes, and you're arguing that this is crazy.
This paper is, and what this paper talks about is how, under circumstances, we can have non-standard refraction where things are different.
Yeah, but we're not seeing that.
Sorry, can I just ask this question of Paul? Sorry,
lights
Anthony.
jiggle up a little bit and down a little bit, but nothing crazy.
That's what I want to ask Paul. So is this picture that we're looking at and have been dissecting demonstrating non-standard circumstances in your view?
Right. In my view, the video of Soundly, what's happening is we see the curvature quite clearly downwards during the daytime leading up towards the evening there, okay? It goes downwards, okay? That's standard refraction, okay? What you're seeing there is the image under circumstances of standard refraction. As the sun sets, we get a variation in temperatures in the air layer above the water. It's not in equilibrium anymore because the sun set. And it takes some time for that air to equalize again, to become in equilibrium. During that period that it takes the air to come into equilibrium, we are seeing non-standard atmospheric refraction effects. Until that air comes to equilibrium, that's when you see the lights come up.
But
okay, and then as the atmosphere settles down during the course of the night, we see the lights start to go back down again.
Answer these questions.
Okay, and that's coming back to standard refraction.
Nathan, would you ask your question again?
That's what Stanley's video shows.
He's not listening.
I am listening. He hasn't answered the question.
Yeah, he did.
No, he didn't.
I have. Ask it again if you like.
That's the problem. You just did it.
Is what we're seeing in that photograph inside or outside standard refraction?
Sorry, Nathan.
Which photo?
The one that we... Are you joking? Really?
The one that bends up.
No. Are you talking about the one that Anthony presented with the lights?
Yeah, the one that's from Sound.
Yeah, the one where he claims that they're in a straight line, that's non-standard refraction. That's during the period of the evening where the air is turbulent, where the air is not in equilibrium.
If that was true, why does it describe non-standard refraction as things like Fata Morganas and mirages?
It describes them also as other things too, Anthony, if you read the paper.
No,
it's
it says exceptional. It uses the word...
It also explains other effects too. It doesn't just explain Fata Morgana and superior mirages. It explains about 7 or 8 different kinds of effects.
So
none of which are minuscule by what we're looking at.
Sorry, Anthony, I just want to clarify with Paul what he's saying. So what you're saying, Paul, is that when it reaches the point that the line of lights is in a row, at that point, it's not standard refraction.
It's non-standard refraction. Yes.
Right, okay.
I would argue it fits completely with the definition of refraction, which is minuscule, and you're arguing that it's not non-standard because it bends up against your model, and only for that reason.
That's right, because it's demonstrating that it's not standard.
So then it comes down to the interpretation of the individual, which is, are we looking at negligible refraction, or is it non-standard refraction and making...
So on one hand, Anthony, you're saying that it's not crazy refraction, and then on the next hand, you're saying that it's crazy refraction because it's bending up and it doesn't fit our curved down model.
I'm taking both sides to the point. What I'm saying is it negligible?
Which is it?
Is it negligible based on the interpretation that Mick West uses, which is the refraction is negligible? Are we seeing negligible refraction, or are we seeing standard refraction becoming non-standard refraction, but not being Fata Morganas or mirages?
That's correct. What you said in that last sentence is correct.
That's ridiculous because that is clearly not that is non-standard refraction. We are seeing it consistent with my interpretation.
That's what I said yesterday. That's an ad hoc.
Non-standard refraction non-standard
Ad hoc
refraction does not
explanation.
have to be extreme refraction.
Yes, it does, because it's either
Bingo.
a mirage.
No,
Bingo.
it does not.
Bingo.
Read what it
Non-standard
says in the
does
article.
not have to mean extreme.
Read
That's
what it
it's
says.
defined as. That's how the definition.
No.
But that's
Read
what
what
it
it
says.
says. It says, right, under standard circumstances, the effects are negligible. It is under non-standard circumstances where we really see some amazing atmosphere. So what you're describing is soundly.
Does it say extreme?
It says amazing. It says
It
amazing.
says amazing. It doesn't say extreme.
Well,
Amazing.
it says amazing,
Amazing.
atmospheric
Okay.
phenomena.
Yes,
So
well, isn't it then
Hold
the
on, hold
lights
on.
up into a straight
Both-
line?
I'll have to turn
Pretty
you both
amazing.
down just to clarify. Just would you say, Paul, that what you see in that picture would be described as amazing?
Yeah.
Yes.
In this picture, I would say
I'm going to bring up the picture again, Anthony. Can we just have the picture once
The
more?
line went from curved to straight. That's amazing.
No, it's
Is
not
it
amazing.
not?
It's
From
negligible.
7 miles.
Hold
From
on.
what is that? 7 miles?
It's negligible.
But what they are describing there, these extreme cases, they do fall into the non-standard category.
So then you've got to decide: are we looking at the evidence where the lights bend up? Are we looking at that as being negligible
Let me
refraction?
get it straight
You-
here. On one hand, you're saying, where's the curvature? Where's the curvature? Isn't it amazing that we don't see the curvature? Oh, but that's not amazing refraction.
Yeah.
No, hang on. Let's put it into context.
How can you do that?
You're-
That's
Right,
disingenuous.
No, let me address that.
flat
So,
Earth proof right here.
so let me address that. Let me go back to the photo. Where is it? Give me a sec while I get it on screen. Is it that one?
Let's look at Mr. Grimm's photo while we're looking at for it.
Nate, could you just share my screen so that people can see it?
I'm on
Wait,
it.
can
I'm
you
on
share
it.
my screen first until he can?
Right, I got it.
Joking.
On one side, we've got Mr. Grimm showing a boat floating in midair, and on the other, we've just got a line of lights on a river. Well, we did have, if you can put it.
Well, is the boat really floating in midair though, Nathan?
Do you know why that boat appears to be floating? Why
Yeah,
it
because-
appears higher than it actually is?
Because it's an amazing atmospheric phenomena.
Looks
The
amazing.
light
I would call
bending
that
down.
amazing.
Also on
That
the
to
bottom
me
of the
is an
The light
amazing
is
picture.
bending down.
No
Amazing
curve. It's because
atmospheric
it's an
effect.
amazing atmospheric
In,
phenomenon.
in
Amazing
its
that.
travel
Amazing.
path, it is
Seeing boats
bending
look like
down.
they're fly
which is
curved is
why you
amazing.
see
It's an
it.
amazing picture.
No
you-
curve.
Mr. Grimm's got up. Amazing.
We were at a particular point. Let's deal with Paul's assertion that what we're seeing is what? Why is it doing that?
How many times do I have to say it?
You're off
You
topic.
need to get the up and down in context.
Yes, and that's what we're just about to do. If I can get this.
Light,
The top of
light,
the boat, the roof of the boat is on the bottom of the boat.
Why is it
light.
doing that?
What happens there?
Hang on. What's going on here?
There-
Why is this doing this?
Well, while you sort that out, light bending down from a distant object gives the appearance of the object being higher out there in your field of view.
Right. Is it still flashing now, Nathan?
No, it's stopped now.
No.
Right. So it's for some reason as it goes on. Right. So Paul's position is that when the light bends up at the end, like this on this particular frame, that becomes amazing atmospheric.
No, you're
phenomena.
about to say non-standard.
No,
and that's
no,
what
no.
I've been saying all along. I have been saying non-standard.
Paul.
You are the ones that are wanting to tag it with
Paul.
extreme and amazing.
Look what it says.
All I'm
That's
what it
saying
says.
is it's
Look what it says.
non-standard.
Do you want
Paul.
to read what it says on screen, Paul? It says it on. It says it's highlighted, Paul. Do you want to just read that word? It says in highlighted. It says amazing atmospheric phenomena. A bit like what we've got from Mr. Grimm V here. That's pretty amazing. That looks like an amazing shot. If I'd have caught that on my camera, I'd be pretty chuffed. This shot, on the other hand, is pretty boring. Let's be honest.
Thank you.
Depending on
Not
how
when
you
it's
look at it.
waving up and down, though.
We are not
It's-
seeing amazing atmospheric phenomena. We're just seeing a little bit of
One-
negligible
It's all
refraction, boys and
subjective.
girls.
One is a more extreme case of the other.
No, one's negligible and the other one's crazy.
Now, we need to address your statement of the light bending up. Now, in the refraction papers, when they
So-
talk about light
Are
bending,
we just disregarding that
They're
whole
not-
hour?
they're not talking about the distant light there at the end of your red line bending up in your field of view. That's not what the light bending is talking about. It's bending down from the light in its path to you. It's bending down in its path. giving the appearance of being higher in your field of view. So when you say the light's bending up, you're referring to the distant object.
While the curved sounds dropped or we've had a network error, we've been joined by Pete Shea. Good to have you here, Pete. Earth to Pete. Come in, Pete. Ah, it's going to be a fake Pete Shea, isn't it, that's just booted everybody? Yep, absolutely everyone booted by Pete Shea. So if the audience can give me 30 seconds, we've still got a good half an hour left on this live stream. So I'll run by my links, and while I'm doing it, hopefully I can multitask and actually get a new Hangout started. So let's try that. Good debate so far. Obviously somebody wasn't enjoying it, or they wouldn't have sniped it. There will be about another 2-minute delay while this Hangout loads itself up, and I can get the link into the info box and into the description. So there is a new link in the info box below, no, not below this video, in the chat, sorry. Well. There we go, that should all be updated. So we've been joined by Make4 already. Good to have you here, Make4. I do like running on OBS, other than literally a couple of mouse clicks. It's like the whole Hangout's been sniped, but we're just carrying on. Sleeping Warrior's rejoined. Good to have you here, Sleeping Warrior.
Morning, morning, morning. Did you notice the snipe was at the exact moment where we were showing how it wasn't non-standard atmospheric being amazing atmospheric phenomena? It was just a little bit of negligible light and bending.
Been joined by Mr. Grim. Good to have you here, Grim V. And all hold off jumping down each other's throats till we've got the majority of the guests back. So we've been joined by Tony and Paul. Good to have you back.
Yeah, I'm back now. I'm not sure what happened there.
All got sniped.
Anthony, don't say that it happened right when you were talking about the refraction.
I wanted to say something, but I didn't even want to validate that with a response. It was so
because yesterday all the Globers got knocked out, so there's no, someone's just being an A word out there,
The same person.
Yeah. It's against truth, both sides.
It was the Pete Shea soccer account, wasn't it? I think.
Yeah, I waited too long because that's the ones that get me. Because if it's somebody's name that you recognise, you instinctively think, "Oh, I'll be alright."
Yeah,
that's why I like to turn my camera on first, even if my volume won't come on fast enough.
Yeah,
so you know it's me, and then I'll,
Grim, though, to be fair, mate, you should turn your camera off.
Yeah. Grim gets a lot more compliments than you, Anthony, I tell you in the comments.
Oh, no. I could afford to be.
Is that why I should turn it off? All right. I don't want
to. I was joking, Grim.
The comments are things like, Grim's a really handsome guy, it's a shame he's such an asshole. Things like that from the women.
I'm not even an asshole, though. That's the thing. I'm just right.
Good debate today, I won't lie. This has been one of the better ones. Relatively cordial, good information exchange. Good debate.
We're missing
Kurt.
This
is good.
Yeah, that's who I'm waiting for. I'm hoping he'll rejoin.
Are we really missing Curved?
Just
kidding.
Nathan, I gotta say,
a very valued participant.
You got something going on here that's a lot better than most flat earthers. I mean, well, not. It's a way better. I mean, it's actually back and forth, and it's consistent, and we can keep going. It's great. I'm just happy to be here.
Bendy.
I agree.
Light.
I think
I like
Curved
the
will
format.
eventually
I like the
rejoin
fact
if
that
you
it's
guys
only got
want
2 hours, so you have to be pretty concise and quick.
to carry on about standard refraction. Curved will rejoin once it gets contentious, maybe.
Can I just say something there? Okay, just getting back to that. Why are we insisting on this dichotomy that it either has to be standard or extreme?
Because this is your model.
There are of course shades of grey in between there. It's not one or the other. You do realise that there can be in between those extremes too.
Nath, do you want to share me?
It doesn't
Yeah,
have
I'll
to
show
be
you on my stereo. My volume switch has
or
1
standard.
and a 50, right? But I can play it on any of the numbers in between 1 and 50 too, just like the atmosphere.
Which is exactly the way standard refraction is described on the International Standard Refraction page that I was citing from. It's not the way that it's described on the Mick West Metapunk website.
I think you just try to bombard with words and you don't really understand what you're saying, because in the beginning he's already explained to you the variance.
I think you're the one that's arguing from incredulity there.
Misappropriated the formula to. We've just went over it all. Do you act like this at home?
Yeah, we did go over it all, and the problem.
No, honey, I did take out the trash. Yeah, but I see it's not taken out. It's Anthony. It's right here. No, honey, it's gone. It's already out. I promise.
You're right. We have
standard extreme is extreme.
I can just get you this.
You can
the trash is right here in the kitchen.
So the question becomes, Paul, are you really arguing that this is non-standard and, quote, amazing atmospheric phenomena, or is it actually the case that this is a little bit of negligible refraction?
Amazing is subjective.
I'm quoting from your science.
You are not quoting. I have only ever said non-standard. You keep putting amazing into my mouth.
I'm quoting
That's
from
not what I'm
MIT
saying.
paper.
Standard is standard, extreme is extreme, and you can have anything in between.
Paul,
Sorry, I just want to
highlighted sentence.
Paul,
that rhyme
sorry,
too.
you're not. I don't know if it's because it's Anthony, but I'll read it for you as well, because it's on the paragraph from the paper that we've been citing loads and loads of times. And it says really clearly, under standard circumstances, the effects are negligible. Full stop. It is under non-standard circumstances when we really see some amazing atmospheric phenomena. What you are saying is, it is non-standard. That would make it amazing.
Yeah. But a little bit away from standard is also non-standard, Nathan.
But it doesn't have that in the definition. It's got,
isn't it?
But that's not what's that's not what's in the definition.
The definition doesn't say that non-standard has to be extreme.
It shouldn't have to.
The definition is saying, all it's saying there is that, yes, we can see some of these amazing things under non-standard.
That's why he went over the idea of what standard was.
That does not
Remember in the beginning when Paul went over?
You're misrepresenting the grammatical, the proper grammatical construction.
No, you guys are misrepresenting.
He actually read it to you, what standard was and how they approached the idea to get standard. So now that you must have not remembered that, or the comprehension didn't set in, so you don't really still understand what standard is, but he defined what standard was.
Right, it comes
massive shout out to Ratio Perfect in the super chat, says, I hate this show.
Or is it simply a little bit of refraction that's negligible?
Neither. You are trying to make it a dichotomy. It is not a dichotomy here.
No, I'm not trying to make it a dichotomy. I'm applying your science.
That what we're seeing here is non-standard refraction. It
Wow,
doesn't
so
have
should we all
to
go,
be
wow,
extreme.
amazing,
It doesn't have to be amazing. It doesn't have to be extreme. Non-standard is non-standard.
And white, Paul.
Okay.
So basically, what your position is, Paul, that we should look at that photo and go, wow, isn't that amazing? It looks flat. In fact, it looks concave. That's what your position is. My
when
position
you were playing it and
is
it was bouncing up and down, that was kind of non-standardish, wasn't it?
Yeah.
Yeah.
Hold on, we've got a new term now. Sorry. Can I just get this new term from you, Tony? Kind of non-standard. Is this a technical term from Tony? Kind of non-standard? Is this a new definition?
I'm just saying, when you play the video, it's curved. You can see it. And then as it goes, it starts dancing up and down. It's bouncing.
That's the end of this debate. We can see it's kind of curved. Kind of non-standard.
All I'm doing is citing your science based.
Yeah, I don't get
Why are you disingenuous, Nathan? Why are you disingenuinely trying to equate non-standard with extreme and amazing? That is not what the paragraph infers.
It's amazing.
Because the show must go on.
That is not what the paragraph infers.
Paul, if he conceded defeat, he'd have to shut down the show and just do something else tomorrow. What is he going to do? Come on.
No. Why do you think that he's been? What was your word? Disingenuous.
Drops mic.
Why do you think it's disingenuous to cite your own
extreme and amazing is non-standard, but so is also a little bit different from standard.
No, it isn't, Paul. Don't be ridiculous.
What? So a little bit not standard is still standard?
Paul, unless somebody goes, wow.
What is it? What is it
then?
If I go a little bit away from standard, what do I call it?
Unless it's negligible, like what?
No, answer me. What do I call it if I depart from standard?
I don't know, Paul. You're the one that's making up the terms.
Call it
it would be non-standard.
That would be non-standard.
Yeah, but the effects of standard are negligible, which is exactly what we see here.
And what I am saying is it is non-standard.
Wow. So
what you really.
So basically, what you're saying is everybody that looks at this, unless they go, wow, then it's not going to be non-standard, is it, Paul? And I don't think anybody would look at that and go, wow, unless you're a baller.
You keep on trying to equate non-standard with amazing and extreme.
Because that's what it says,
non-standard just means not standard.
It's there.
No.
Do you want me to read it again?
A little bit above standard is non-standard.
It says, it is under non-standard circumstances when we really see some amazing atmospheric phenomenon.
He's not intaking any of the details there.
Yeah.
He's not
you got
on them. He's not using the mechanics. He's not trying to understand what you're saying at all.
Yeah, you got two laymen
trying to agitate you. That's the name of this game. They try to agitate you and make you act like, a fool, and you end up doing it, after a while, because after you try to fix this problem, you're a fixer. You're trying to fix this guy's problem, right? He's so broken that it's irrational. So try every rational move you can, and then the last thing that's left is you become irrational with him, and that's what they're trying to get you to do, bro.
Anthony, the standard kilogram is 1.000 kilograms. What if it's 1.001? Is that standard?
In the context that we're talking, I'm going to assert that a boat floating in the air would satisfy the definition of some
extreme and amazing
atmospheric phenomena. In contrast, a couple of lights that are bending up a little bit at the end isn't. Wow. So let's
play that video. Play that video.
I say it's amazing.
Standard.
I say it is amazing to bend light.
Yeah, I think
even a little bit
is amazing.
Yeah,
I think it's amazing, bro.
Is claiming that it's amazing.
Actually,
Flat Earth
your
is
argument
saying
is subjective.
You're all naked because you're wearing the
Your argument is a subjective argument. You're like, what do I find beautiful? Is this beautiful or is that beautiful?
No,
well, no, that's not beautiful. Well, who's the judge of beautiful? You, Riley?
Yeah, but we're all able to distinguish what.
Okay, is it a square or is it a rectangle?
Now, a floating boat in the sky is amazing.
Yeah, are those conditions the same though?
What year is it, Riley?
Yeah, but we're all looking at the effects of the refraction. Is one of them a wow, or is one of them
on? Everybody, I don't even know why I'm just.
What are the conditions present when that boat is seen to be appearing to float in the air?
Well, if we're going to go down the route of what conditions are present,
what are the conditions present there, Riley? What are the conditions? I would say it's probably more than that, Riley.
Yeah, but if we're going to go down that route, then we don't need to apply these maths, because I agree this is where we should be looking. We should be looking.
Well, of course, yeah. Why would you apply standard refraction to non-standard conditions? Good point, Riley. Very good.
Yeah, pressure, temperature, density, and viscosity of the Earth's atmosphere. That's
I would like to, Anthony. I would like to do the equation for us on pen and paper for us.
Hold on, Curved and Anthony have just got to a nice conclusion here. Can we just actually hear their conversation, because they're reaching a crescendo, if that's the right word?
Well, we just got to it. If we're talking about the pressure and the density and the viscosity of the atmosphere, all these factors are relevant, and I agree. However, the maths is not based on them. The maths is based on an arc.
No. Wait.
Yes.
What? The 7.6 is based on, it is an approximation based on the standard.
No,
atmosphere.
Based on a radius.
No. Oh my God. The radius.
The air is
That's the
denser
problem right
towards
there.
the bottom, right? You
The
get
radius
that.
is
Based on a
used-
radius.
The
the
air is denser
radius
towards the bottom, so the standard would always be a tiny bit.
The radius
Boys.
is used to incorporate the conditions.
Boys,
Why
it
can't you
says
see that?
based on a radius.
That is used to approximate the conditions.
Doesn't say that, Curved.
What?
Doesn't say that.
My God, it's clear as day.
No,
highlighted.
it's contradictory as day.
This
This
is
is
what's
what
going on.
happens when you actually
Again.
study it and go to school. You learn these little the things in between, not just
No, this is
written
what happens
down.
when you use your science against you. It contradicts itself, and it
Riley, do you understand that
relevant.
the ISA page is not about curvature? It's not
We're not
giving
talking about
you
curvature.
values for the calculation of the drop.
We're not talking about the curvature or the drop. We're talking
They're
about
not.
the refraction that you guys are making it look like it's flat.
That's what the 7.6 is used in generally to approximate.
Yeah, but it's supposed to be based on the pressure, the density, the
It
viscosity.
is. It
It
is. And when you apply
based-
those things, that's what they come up with. 7.6 radius as an approximation.
No,
This
radius
is really
has nothing
simple.
to do with it, but it's calculating for you.
I understand. You can't accept that. It kills your case here. You've
I don't
argued
think
this
you
too
understand it.
long.
I don't think you do.
You can't admit it. You just
Wow.
can't admit it that you're wrong.
No, you can't admit that radius shouldn't be there, and it's but the whole calculations here are based on it.
Riley, you don't even realize that applying 7.6 radius results in less curvature.
What are you talking about?
Really?
From the 6.6 to the 7.6.
Going your way, dude. That's refraction
It
in
makes
your
it appear flatter.
radius away from the Earth, dude. Radius away from the Earth. The arc is the other way, bro. You're arguing
does
against
the-
yourself the whole time.
Yeah, it's crazy.
This
What
whole
does, the
time.
what does the highlighted sentence say on my screen?
I knew he didn't understand what he was looking at. I just wanted
Yeah.
to clear.
You sound like Miles Davis, you lot in disguise.
All right, what does it say?
What does the highlighted sentence say
Except
on my
you can
screen?
clearly see who I am, right?
Yeah, but don't forget this is coming from Mick
Or do
West
I not
himself.
exist, Riley? Am
It's
I,
irrelevant who it comes from.
can you add me to the equation?
Look, right, read it. Read that top line.
Miles,
It says
I
the
don't know what
value
that
of
is.
7.6R is just a rough approximation of the effect of refraction on the apparent radius of the Earth.
There you go.
It's
On-
a very approximate
Wait,
as the
on
atmosphere.
apparent
Then you let me
radius.
read it. Is a very approximate as the atmosphere is quite variable. Basically, though, you do the same calculations, but the larger radius gives you the reduced curvature. What
Yeah.
they're saying here is that they account this equation accounts for the effects of the refraction.
But it's
Okay?
based on an apparent radius.
That's right.
Radius.
That's right. That's
It's not-
right. What it tells you is that it increases the apparent radius of the Earth
All
to
right, let me
account for
rephrase
the
it so that it's
refractive
correct.
effects.
Let me rephrase
Okay.
it with the words that would then make it correct, and you can tell me if I've got it wrong. Okay? The value of 7.6R is just a rough approximation of the effect of pressure, density, viscosity, and temperature of the atmosphere, or whatever them four values. That's what it should read, not on the apparent
That's right.
radius.
No, you're correct when you say that. If you replace that word refraction in there, if you replace that word refraction with density, pressure, temperature, humidity, everything like that, all right, that's what it's doing.
No, it's not.
Summarizing. It's pulling all of those effects into one
That's right.
correction.
If you replace the
Remember
word.
when I told you that's the data points that I needed in order to make an assertion and correct?
Yeah.
You've just said it yourself. If you change the word,
Exactly. What's
then it
happening
makes
here
sense.
is that we are taking into account all of those effects and pulling them all together into one correction that we make to
Yeah, but the
account
correction
for
is
that
based
refraction.
on an apparent radius. It should be
That's
based on
correct,
pressure,
but it's
density,
still that's
viscosity.
no, but that's what we're doing. We're adjusting the radius to compensate. That's what we're doing.
But there is
We
no
are
radius to compensate.
accounting. We're compensating for all of those effects by doing that.
No.
The effects, remember that we
That's
can
what's
repeat in the
happening.
laboratory. We know those are the effects that
Yeah.
occur. That's what
Right.
you're forgetting, dude.
If you
It's
want to
not like these
believe,
effects are mysterious and
we're
we're only
saying-
guessing.
is consistent with the 2 MIT papers that we've just been through, then you believe
What
that.
we're saying
you are
is that
indoctrinated.
we tie up all of those effects.
I'm
We
indoctrinated.
tie up all of those effects of humidity, temperature, pressure, everything like that. We tie them all up and we bundle them all up, and we make a correction to the radius of the Earth to account for those effects.
That's the point, Paul.
That's what we do. That's how we account for it.
Paul,
hey, real quick, can we get to that
apparent
link?
radius?
Can we get to what?
I tried to get to that link there that Nick
They
says
already know the
initially
radius
got the
of the Earth.
7.6 value.
Hold on,
from.
Paul's just made a
There's
whole.
probably very good information at that link. I tried to type it out. It's not working for me.
Sorry to interrupt, guys. We've got about 10 minutes left, and Paul's just had a long period of time to explain something. Can Anthony just get a couple of minutes just to respond to him?
Can anybody read that? That paper would be fantastic.
Did you want to respond to Anthony?
What are we?
The link that Mick says he got the 7.6 value from at the SDSU, San Diego State University. There's a link there, but I can't click on it.
Hang on,
Okay, while these guys figure out what they're doing with their link, I'm going to do my link. So if you are new to this channel, or you have not done so already, which is about 50% of the viewing audience, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live. And most importantly, if you would like to join this or future panels, simply click the link in the info box below this video with the page you are currently watching on mute. There are a couple of rules in the Hangout. Number 1, please do not swear. And number 2, if you are ejected for swearing, please do not try to rejoin the show using sock accounts. Thanks a million to all the people who have shared this stream. As you probably just heard, there's about 10 minutes left on this particular live stream, so share, as it increases the live audience, which increases the chances of having a more diverse panel. I will come back one more time just to thank the audience for being here and thank the panel. So if in the meantime you did want to join, click that link in the info box below this video and subscribe if you've not done so already.
You're not even on air right now. Nathan's just yapping on air, and
yeah,
that's okay.
I would
he's coming
like
in to close
Anthony
the show.
to actually us give him numbers to put into that equation and have him do it on paper so we all can understand he knows what he's doing instead of just punching numbers in a computer. That would be really great for me, at least.
Thank you, Paul.
That would confirm that we know he knows what he's talking about, at least.
And if nothing else, Riley can take that link that Paul just posted.
Yeah.
Riley can go through that today after this hangout's over, and he can either read through it, understand it, and see where the 7.6 comes from.
I understand where it comes from.
And try to argue against it.
I understand where it comes from, and I don't need to argue against it. The point, the arguing point isn't about the 7.6. It's the fact it's based on the radius.
It is. You thought it was backwards anyway.
My God, 7.6 is the radius that they use. What are you talking about?
Yeah, but it should be based on the pressure, the density, the viscosity, and the whatever the other one was.
Oh my God!
But this is how they found out the Earth was round. I think you're confused.
No, I don't think this is how they found out.
This is how they found out the Earth was round. So they already know
how they found out that the Earth was round.
That's how they can use this to create this math in the first place.
Well, you guys believe what you want to believe, but the simple fact
where does that come from, though? How, can you show us that?
Who was that aimed at?
I think it's aimed at Grim. He's asking how the presuppositional argument comes into play. That's what he's asking, I think.
Well, I'm saying this is what they are using. They are using what they already know to be the radius of the Earth.
Is he asking me or is he asking somebody else?
Look, in the beginning, they go.
I'm not asking anybody.
They go through no refraction.
Grim said there was previous history of how they calculated the curve, so I was just interested.
I said this refraction math is not how they calculated the curve. Any arguments with that of the Earth?
Yeah, that's not how they calculated the curve of the Earth.
I know. So it seems like you're expecting to be able to not know the circumference or the radius of the Earth.
Before
adjusting for observations on the Earth.
Right. So, let's just conclude because we've only got 5-10 minutes left.
Right. But you must know what the terrain is first before you start making corrections to the observations of that terrain. Must you not? So what would follow, then it would follow that they already knew the radius of the Earth before using refraction math.
Well, we can all shut up shop then,
I
Grim.
have
We
no
can all
idea
go
what
home.
you're talking about.
If this has already been
then if you don't have
decided,
any idea what
let's shut this
Right.
down and go
Can
home.
I make a conclusion, Paul, and then give? Can I make a
Just
conclusion
quickly,
and give
just
Paul
quick-
the
just
final
quick.
word?
Just quickly, Anthony, if I can say,
Is that
this will
not-
only take 10. This will only take 10 seconds or so, Anthony. I'll get this in, and then you can say whatever you like to me. Okay? Can you just share my screen for a moment now?
Yeah. You're
Okay.
sharing, Paul.
The 76R. If you were to read this part, Anthony, which is that link under that 76R, this bit here explains where they derive that 76R from.
Yeah, I
If you
understand.
read that and try and understand it, that's where they derive it from. They explain where they get that from and why they use it. That's
Yeah,
all
but they
I'll
should
say
be getting
there.
it from
Right.
the effects of what
but
they say that they're getting it from.
They explain there how they do that, how they incorporate all those pressure changes and stuff
Right, but
into
listen.
that 76R. Okay,
Paul,
so I'll stop sharing now, and you can say what you like.
Let me respond to that. Do you agree that on the Metabunk website, he says clearly that it's based on 76R, right? Which is supposed to be an approximation of the refraction expected under the standard atmospheric conditions. But when you click the link, firstly, it takes you to the international standard atmosphere. But in any event, the link takes you to pressure, temperature, density, and viscosity, and then it gives you the maths that are underneath. That is not consistent with what the Metabunk website calculates for, because it's based on a radius. Now, ultimately, we go back to this simple. Go back. Oh, hang on. Was that sharing then?
Yeah, I stopped sharing it because I thought you wanted to talk to me. That's all.
So no, I didn't realize that mine wasn't sharing. Basically, right, it comes down to this. If your argument is that it's non-standard refraction, everybody that looks at the bit with the lights are bending up at the end must react with going, "Wow, that's so impressive." But my position is it's simply refraction, and it's negligible, and all these individual lights will move a little bit up or a little bit down depending on the refraction, and it's negligible, which is consistent with what we see. So basically, if it's non-standard, you've got to go, wow. If it's standard, it's negligible. Which one do you go
And
with?
that's where I disagree. I'm saying that non-standard doesn't have to equate to wow or extreme. Non-standard just means it's not standard. You can be a little bit not standard, or you can be a lot not standard, but both are not standard.
Well, you can interpret that if you want to, but the true normal interpretation of the evidence that we've got available is that it's not anything that would make you go, wow, look, there's a boat floating in the sky.
And it doesn't say that that's what they're saying.
But it does. It says.
No, it
that's your interpretation. You made the false dichotomy.
I haven't made a false dichotomy.
You made it black and white. You made it black and white and can't see the gray.
Took out all the variables in between and said it's either this or black, white or black.
That's not good logic.
When all these other colors exist, and they are existing, all the different variables in between can occur, and they can be ever so slight, and they can go for a longer period of time, ever so slight, to create a what seems like a much more extreme version of what you're thinking. But since it's over such a long distance and so gradual,
so ultimately,
it's a pretty slight boat, just like floating in the air, man.
Laming it up for you.
Do we all agree that it's the interpretation of what this sentence says? It is under non-standard or Paul circumstances where we really see some amazing atmospheric phenomena. My position is there's nothing amazing about this.
That's when we really see amazing atmospheric phenomena, right?
The amazing.
We can crank it up all the way because we got a big old amplifier is what they're saying. They're not saying everything else is cranked up all the way. Everything else. No, they're not. They're saying we could. It could.
They are in the non-standard category.
Got 60 seconds left.
But that doesn't mean that everything non-standard.
Nobody honest would think that. Only Curved would think that. And then Grim would support him.
Everybody honest realizes it.
Yeah. Standard wouldn't sit there and dance up and down, dude.
No,
standard doesn't dance
you
up
don't
and
even
down.
understand.
That is the perfect illustration of standard refraction. Negligible changes on based on the variable of the vertical pressure variance on the gas.
So bending them in a straight line is negligible.
It's the application of exactly what's described.
It might be standard for the water right there.
It's the application of exactly what we see here at this maths.
It's not standard over the idea of being.
The mathematical model divides the atmosphere into layers with an assumed.
And with that, I'm going to say a huge, massive, enormous thank you, first and foremost, to our live audience for joining us on this debate and for sharing the show, which I am eternally grateful for you all doing. And of course, a massive thank you to all of the panel for making this debate possible. Be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I will see you all in the next video.